Hey, on this one, I'm going to artificially run our heater box motor to see if the motor operates and to see if it operates in all speeds. Speeds on this motor, because it is only a 2-wire motor, 12-volt DC motor that uses 12 volts to run it. But what we're going to do is control the voltage through what we call a resistor block. And on this older unit, which makes it easier to see, we're able to pull this resistor block out and see what it consists of. Of course, this fella has these wires that do tend to get really hot and burn up, hence the reason for mounting it inside a heater box. And on this one, through the heat, you can see how the terminals have even corroded down here on the bottom so heavily because of the heat that's generated in these. So, and with that then also, if we look at these and we can see how 2 resistors are hooked on one's on this one, one's on this one, 2's on this terminal, we don't know how to physically go in and attach wires to make this run. So we're going to have to use a wiring diagram to come up with that. If we go to the back side of this unit, we will then have our connector view on that. And we're going to look at some paperwork that will show us how to get into our connector view. Now if we look at this one first, right off the bat, on what we do have here, you're going to see 4 pins on the inside of here then. You're going to see your connector assurance lock here then. And then one other thing, note in the very bottom, and this helps you on your connector view of what's going on, note the 1, 2 indexing tabs on that side, and then on the top side, notice the 1, 2, and 3 indexing tabs that we have right here on that. So we can use that to help us on our wiring diagram. Now for that wiring diagram, I've gone to our media that we have and printed it off, and I've gotten 2 sheets of paper. One's going to be the overall wiring diagram, the next is going to be the connector view, so I know which terminal is which on this. If we go to our actual wiring diagram, of course we have our source, protection, control, and then device, and then ground with this Valley Forge design that we have here. Of course we have our blower motor indicated by the round circle armature, you could say, with the brushes on that. But over on this side is our actual resistor block that we have out, and that's what I have to worry about jumping across, because we have 1, 2, 3 inputs into the resistor block, but only 1 output of it that's going to then feed my electric motor. So out of these 1, 2, 3, 4 pins, I have to know which pin is actually the one that's going to supply the voltage to the motor on that. Now, because wires get crossed and so on like that, these manufacturers always draw our lines in a straight line. This is a pin out of our connector, and right now I'm highlighting 4 letters that we need to take into account on that. And if I zoom in on this guy a little bit, you're going to see that I have a D, a B, an A, and a C. So we know that's not how the alphabet goes and so on there. But again, these aren't in a particular order because they've had to draw the line straight on this. But it still gives me my 1, 2, 3, 4. And on that, if I was to take and turn my control switch to a speed with this wiper and off, I have no connection between any contact there. When I then go from off to low, we send the electric across this contact down this shunt or wire, and this wire then sends the electric through 1, 2, 3 resistors before it's then allowed to go to the electric motor itself. So each one of these resistors will give up some energy and we'll have a voltage drop across each one. If I went to medium 1, we come down and we use 2 of these resistors in conjunction with each other then to give up some energy. So means we eliminated this one, we will have a faster speed, we'll have more voltage applied to the motor. If I go to medium 2, we can see that we bypass the first 2 and only using the last one. So this wiring diagram helps tremendously in the way they sort this out. But again, our resistor block in no way is sorted on the pinouts that we could figure it out off of that. So I've got to come and find the connector. And when I say connector, it's going to be the view of the opposite end of this. So we've got a printout of this that we're going to take a quick look at. And we're going to look at the information available on this. And we can see then that we have our, in green, A, B, C, D, so it's in a logical order there then. That makes up for the crisscross of all the wires. And the yellows are connector assurance. And in the pink that we have right here, you'll see 1, 2, 3 and 1, 2. That gets us back to the actual pins or the locating tabs that limited us on how these go together on that. So the 3's on the top, 2's on the bottom of it. And what we have to do then, our next big factor, is this is a picture of the connector, not of the device. So that means that this unit comes in and flips over. So A is going to be here, B, C, D, hence the reason for the alphabet going backwards on this. So if I bring this over and I keep my finger with A, I then have inside of here my A, B, C, and D, giving me, and I wrote those with a highlighter on there then, A, B, C, D, telling me which terminal was which. Now when I go to jumper, I'm then able to come down and jumper battery voltage to A, and A is going to be a higher speed because of the lesser, B is going to be of a medium speed, D is going to be the low speed, and C terminal is the output of that unit. One more thing on connectors while we're in there then, let's finish this page out. Here we can see we have the complete part number that would be for the plastic connector assembly itself. So that's a GM number that we could use that. On down it says it's a 4-way connector, 1, 2, 3, 4. It's an F Metra pack, and that means that's the type of terminal that we have in that. And this is of a female Metra pack, so it's a female terminal. And then we'll see the 480 on that, and that's actually 480 millimeters, or 4.8 millimeters, if you will, across the terminal itself then on there. And of course it's a black in color with the blower motor. Now what's that 480 and a Metra pack mean? If I go to a pack of terminals and I come in here, and I'll show you that exact numbers and so on that we had, you'll note that we then see Metra pack, we see 480, I see female, Metra pack 480 female, but I have a possible difference because of the gauge of wire that feeds to it there then. So you're then going to have to go back to your wiring diagram, and on our wiring diagram we can then decide what gauge wires these are. And if we take a quick look here, we can see a 0.5 yellow, a 0.5 tan, a 0.5 light blue, and a 0.5 dark blue. So that 0.5 is the size of the wire. If we look at this container here, these terminals are actually for a 1 to 2 gauge or a 3 gauge wire within itself. And then one more time, if I did take one of these terminals and I had the male end that goes along with this unit, and we was to glance at this with the male and the female, and we could see these come together like that, that 480 again is the width of this. If I took a scale and on that I came over with this stop gauge on there and I measured across this and evened him up, we'll see that the graduations that I used up is 1, 2, 3, 4 and a little more. You could get a little more precise on that. You could take a caliper, measure the width, use the lower scale because that's the metric, and on this lower scale we've then passed 4 millimeters, but we're not quite to the 5th one, so we go to the lower scale, come across, find out who lines up, and note that the 8 is lined up with there, so it's 480 is the width of that terminal. So now we know the terminal, we know the size of the terminal, we know the location of these terminals, the opposite way that we have to jump. We know that it's in with that off of this diagram. We then know that C is going to be the outlet to the motor, A is going to give us medium 2 speed, B is going to give us medium 1 speed, and D is going to give us low speed. We'll hook that up in the next section to see this operate then.